Good afternoon, good morning, good evening, all of you. We're so happy to be here back. My name is Yonas Alem. I'm the director of the Environment for Development, and usually we don't introduce our chairs, but I have a very happy announcement to make of our current chair of the session today, Professor Martine Visser. She's not only a very renowned professor at the University of Cape Town and the director of our EfD Center at the University of Cape Town, but last week, all her peers, all the center directors making up the coordination committee of EfD voted her to be the new chair of the EfD coordination committee, and thereby also representing all the EfD centers in EfD's advisory board. So congratulations, Martine, and now over to you.
Thank you, Gunnar. It's a real honor. I'm also very honored to be here today, chairing this plenary session with Professor Yonas Alem. I'd like to give him a short introduction, if I may. He's going to be talking to you about weather shocks and livestock production, looking at some insights from sub-Saharan African panel data sets. Yonas is a senior research fellow at EfD, but he's also collaborative PhD programs director at the Department of Economics at University of Gothenburg, where he received his PhD in 2011. In the meantime, he's kind of raced ahead of all of us. He's in the meantime served as a research director of EfD between 2011 and 2019. He managed to be a visiting researcher at the University of California, Berkeley, and also at Brown University. He's taught a wide range of very complicated econometrics and statistics, things like impact evaluation and causal inference, what most of us hardly understand. But he's also worked on a very important, potent research in developing country context in Africa on poverty, economic development and environment in developing countries, and more recently shifted to working predominantly on behavioral development economics, thinking about how psychological and behavioral economic applications can be used when one looks at poor decision-making of economic agents in developing country contexts. And so he's got a lot of ongoing research investing in consistency and intertemporal decision-making, looking at risk and uncertainty, and also working on large-scale RCTs and lab and the field experiments. So really a lot of overlap with the work that I'm also doing, which is why I follow Yonas's work carefully. He's published in a lot of high-ranking journals in our field. So he's really one of our top researchers in EfD. We're very proud of him. I make a point of not questioning his research methodology too much, and I think you should also be careful of that, because besides all of this, as far as I know, Yonas also have a second dan black belt in martial arts, so do look out. Yonas, I'm handing the floor to you.
Thank you very much, Martin, for that generous introduction. I know Martin from back all the days when we were PhD students at the University of Gothenburg. We had a minor overlap. I greatly appreciate your mentorship during my very early first PhD years. Thank you very much, and it's very good to see you here again. I want to thank everyone, and especially EfD as well, for inviting me to give this keynote speech. I grew up in EfD, both, physically, as you can see, and also academically. I started working with EfD researchers, and especially with Gunnar and Thomas in 2003 when we started the first EfD center in Ethiopia. So most of my, quite a significant part of my work was funded by either CEDA through EfD or directly through the collaborative PhD program. So I'm truly grateful for all that. My work, coming to my academic work, most of my work, of course, overlaps in both development and environment. I did quite a lot of my work on shocks, adverse events that affect households' welfare in developing countries, but most of these shocks are also caused by climatic events. So one of the reasons why it is overlapping with climate and climate change is also because of my work on shocks. And I also worked on technology adoption, like fertilizer adoption, improved cook stoves, solar panels, LPG gas stoves, improved seeds, etc., etc. Again, which overlaps with environment and energy issues. So it is based on that kind of understanding and drawing that research that I would give this presentation. So as you can see, the title, as you saw, is on the impact of climatic shocks. Most importantly, we're going to, I'm going to give in some results, share results on interesting work that I did with one of my PhD students from the collaborative PhD program on the impact of drought on the livestock sector in Ethiopia. So I would like to start this presentation with the stylized facts when it comes to development and environment economics. Risk and shocks are common in developing countries. That is, they're very highly, households in these countries have to cope with both risk and shocks. So risk is an ex ante concept and shocks are ex post concepts. So risk is before it happens, you are operating under risk and uncertainty. That part is an ex ante concept, but very often, of course, you see people confusing both terms, but risk is an ex ante concept. Before the shock happens, and shocks is the materialization of the risk. And the households mitigate risk, whereas they cope with shocks. So both these risk mitigation strategies and coping strategies have implications. The risk and shocks that households face, mostly in Africa and South Asia, are covariate shocks, example, drought, natural disasters, conflict, political instability, and idiosyncratic, like pest attack, illness of a household member, job loss. Idiosyncratic shocks happen within, in a village, it might happen to a few individuals or one individual. Covariate shocks affect the entire village in the household, in the community. So the second fact, stylized fact, is of course documented by the number of studies that have been produced, is there's lack of access to formal financial credit insurance institutions. So households have to deal with these shocks and risk by themselves by forming informal risk mitigation shock coping mechanisms. There are, for example, strong evidence in development economics showing that kinship within a village kind of risk allocation arrangements, because these kinds of arrangements can you can mitigate the problems of moral hazard and enforceability issues, and then you can make some sort of efficient risk allocation within the household. So you can verify if a household is facing within a village a certain shock, and then you can pay out, support each other, and then the consumption of the household will not be significantly affected. And households also use consumption smoothing, other own risk mitigation strategies, both ex ante and ex post, which have both ex ante and ex post implications. Let me start with a brief background on the type of shocks that households experience. This is the data from the most recent panel data, Ethiopian Socioeconomic Survey, from collected nationally representative data. So the top three, you can see I colored them in red: illness of a household member, drought, unusual price rise. So inflation is also another major problem, of course, in many parts of Africa, related to mostly government policies such as printing money and the budgetary issues, and also rising the price of food globally as well, 12%, drought 13%, and illness of household members 17%. Tanzania, this is from the Tanzania National Panel Survey, 2019 and 20. Drought or floods, 29% of the household experience of that, and crop disease or crop pests, 20%. And large rise in the price of food, again, 35%. So you can see that at least in the three countries that I show you, this is from Nigeria. So the three countries, Ethiopia, Nigeria, and Tanzania, constitute almost like probably 30% of the African population. Nigeria is the largest, the biggest country in terms of population size, and Ethiopia with 110 million people is the second. So this is basically only three countries, but large sub-Saharan African population. Death or disability and flood, again, increase in the price of major food items. So in all these panel data sets, we see that drought and climatic events are actually in the top three all the time, depending on the year. In 2015-16, for example, in Ethiopia, of course, it has been more than half the population that was affected. I will come up to a descriptive statistics on exactly the specific shocks that we're talking about. I just wanted to comment briefly on the framework that we use in analyzing the impact of shocks. I'm not going to go into detailed mathematical derivation of this. As you can see, it's only to give you the insights on the objective functions and the constraints, and then how we use this framework actually to see the ex ante and ex post impacts of shocks like drought. So if you consider a standard utility maximizing household, basically the household is maximizing a lifetime utility, and where, basically consumption is the center of utility is a function of consumption, where delta is a rate of time preference, and the utility function, the consumption function, is twice differentiable. And there is income, YT, that the household earns. This is a typical farm household, you can call it. A function of technology that it uses, that's the input that it uses, xt at t minus 1, which is decided ex ante. Assets evolve with an interest rate R. What it means is the asset that the household has is a result of the asset it had previously plus the income it earned less the consumption that it consumed plus some sort of premium. So if you put your money in a bank, basically you get interest rate. If you put it into a farmer, you just save your asset in the form of livestock, which increases its value next period. So insurance markets are missing. Key fact of this model, or this framework, is in each period the household faces AT and realized AT is the asset, unrealized income, Y, and chooses both consumption and asset for next year and the technology that it uses. Combined with a T plus 1 will generate a particular risk distribution. So what is interesting here is decisions on X and A, which is the assets that you have, and also the technology that you use, should be made ex ante, and which is called risk management or mitigation strategies. Once income or outcome is realized, the household could be facing a negative, positive, or no income shock. So if a shock happens, basically a household will smooth consumption using coping strategies. Okay, so far it's all good, but what is here is the major message that comes out of this is with a missing or imperfect credit insurance market, these decisions have both short-term and long-term costs on the household. So a variance of this framework have been used to model decisions of households in developing countries. A good example, for example, is if the household is facing risk due to rainfall pattern variability, significant variability, it uses basically less fertilizer. The fact that it uses less fertilizer is a risk mitigation strategy, but it would have a negative effect on the household because yield will not be as, the average yield will not be as it could have been with the use of the technology. Then that takes us to what we call the risk-induced poverty trap. Different households will be trapped, poor households will be trapped in poverty, whereas richer farmers or richer households will take advantage of new technologies because they can afford to take risk. So these are a brief finalization, like kind of summarizing a table of these uninsured risk, and then the risk management strategies. So you have to manage risk, and then it has implications on your outcomes. And then the risk is materialized into a shock. And then when the shock is realized, then there will be a shock coping strategy. Again, it has implications for outcomes in the short term and in the long term. So this is the framework that we use to model the impact of both the ex ante impact of risk and also the ex post impact of shocks. So specifically, talking about the impact of the El Nino-induced drought on milk production in livestock. So we are interested in measuring the impact of the 2015 El Nino-induced drought on the livestock holding and milk production. The motivation is straightforward. What I have discussed in the past 5-10 minutes, it's just households are uninsured through even covariate shocks are uninsured through formal mechanisms because everybody faces within a village, the shock is felt by everyone, so households don't insure themselves. And it has large impact on welfare, both short-term and long-term. So what we do in this study is we identify the impact of the 2015 El Nino-induced drought and two outcome variables. One is livestock holding, which is described here in tropical livestock units. And the other is milk production, or we call it dairy production, but we use milk production because the questionnaire, this data set that we use has a rich livestock module where they ask how much milk they basically milked during the year. We have panel data collected before and after the drought. So this gives us kind of the ideal setup to use or to identify the impact of the drought using a difference in differences analysis. A brief comment on this specific drought. So El Nino is, as we know, probably the unusual warming of sea surface temperature in the tropical Pacific occurring every 2 to 7 years. It happens between 2 to 7 years when the sea basically surface warms up. There's an exact opposite phenomena called La Nina, but that is more caused by cooling. El Ninos are caused, have known to cause heavy rain and flooding. The 2015-16 El Nino is notable in its strength, its negative impact on crop production, livestock, and agricultural livelihoods. Worldwide, it affected over 60 million people. So in Africa, the main effect of the El Nino event that happened there at that time was drought. Ethiopia was 9.7 million people became food dependent. Somalia, 4.7 million. Southern Africa region, like 40 million. And Sudan, about 4.6 million people. In Latin America, we also witnessed drought. Haiti, 3.6 million, large, and Central America, about 3.5. In Asia, that was combined with drought, cyclones, and frost, with, for example, Fiji and Papua New Guinea, about a third of the population being affected, and Vietnam basically being affected 83% of the country. So it was very large scale and intense. So in Ethiopia, it resulted in failure of the 2 consecutive rainy seasons. So the bulk, which is the spring rains, that is important for 10% of the annual production, erratic and delayed meher or summer rains, which is also 90% of production. So farmers produce 90% of their production through this rain, whereas 10% comes from the bulk. But you can see that the bulk rain in this season is small in terms of its contribution, but actually if you look at it, there's some evidence produced by colleagues at EfD showing that these 10% rains are really very important for crop germination and other agricultural production in the main season. So if the rain in the short season, which is in the bulk season, fails completely, there will be drought no matter how the rainfall in the main season is. So the impact has been really significant. It was the worst drought the country experienced in decades. So like say 10 million people required emergency food aid. There was also reported livestock, large livestock mortality and morbidity. So what we do is basically we add to the literature on the impact of climatic shocks. There's large documented evidence on agriculture, how climate is affecting agriculture. Extreme weather events like drought are becoming more frequent with climate change. Climate change is also shown to have made El Nino events more frequent and more intense. This is according to a new publication by Wang and co-authors published in PNAS in 2019. So we expect these kinds of effects to happen more often and more violently as well. There are relatively more studies on climate and crop production, both in developed and developing countries. Famous Drechenson, Greenstone, Lobel, and Carter, Olson, and Bindi, all these, Shalanker, Roberts, the known effects how yield basically responds to climate variables like climate change. In developing countries, we have Mendelssohn, Salvatore De Falco, and co-authors as well, 2011, Chen, Zhang, 2017. The last two are actually two most recent papers from China where authors have used actually climate variables, not only rainfall and temperature, but also wind speed and sunshine and et cetera, and their interaction on yield. What we see is not many studies, of course, in sub-Saharan Africa, not many studies on the impact of the livestock sector, but this sector is important. Global calorie consumption, 70% comes from the sector. Global protein consumption, 33%. Employment, 1.1 billion people. So especially in poor developing countries in Africa, especially in the Sahel region, West Africa, Southern Africa, and East Africa itself, quite many people, actually many tribes, relying on livestock. Livestock herders population is pretty large. It is expected to grow exponentially in the developing world because of increase in income and improvement in living standard. So the effect of climate change on the livestock sector climate change is expected to result in reduced feed crop and forage, reduced water availability, reduced animal growth and productivity, and also frequent disease outbreak. This is how climate change affects the livestock sector. Of course, as environmental economists, we're also aware of the negative contributions of the livestock sector to climate change in greenhouse gas emissions such as methane and etc. Of course, but that part is not covered in this because we're considering smallholder farmers basically who are having probably 5 cattle or 4. I'll show you the descriptive statistics. These are like smallholder farmers whose main livelihood is production, agricultural production, but they use livestock as well. So we offer insights using data from Ethiopia. Ethiopia is highly vulnerable for drought. 15 droughts since the 1960s, the country experienced it. And Ethiopia is also a country of paradoxes, as some of you know. This is the richest country in Africa in terms of the number of cattle, and it's the 5th richest country in the world. When you consider the entire livestock, Ethiopia is still #1 in Africa, but 10th in the world. So here, this descriptive statistics is on cattle population. So we tease out some of the mechanisms. So we measure the impact, see the impact, and some of the mechanisms that explain the change. So this study also speaks to the literature on shocks in development economics. Covariate shocks are uninsured through informal mechanisms. So both short-term and long-term effects because of covariate shocks. Lower technology adoption, there's quite a bit of published paper in that, how households use less fertilizer and improved seeds in modern technologies. Household consumption, this is clear. Derken has quite many actually studies. The most important ones are these two. During drought times, households reduce food consumption, and especially children are affected significantly, and vulnerable members of the household. And there's always school attendance, child labor. Some households actually withdraw their children or make them miss classes to work for outside of agriculture just to generate extra income in times of shock. So losing a livestock may have a long-term welfare implication for poor households. For example, if you lose a pair of oxen due to drought, basically that is the most important capital that you use actually to plow your field when the rain comes back next year. So this has major implication for welfare analysis, poverty analysis, and social support and safety net programs as well. This is Ethiopia. Located in the Horn of Africa, bordered with Eritrea in the north and Sudan and South Sudan in the west, Kenya in the south, and Djibouti and Somalia in the east side. So you can see that quite a large part of Ethiopia is highland, is like both highland and lowland, almost 50-50, but quite large proportion of the population, 80% is settled in the highlands. So the dots actually here show you where the study areas are, or the study villages are. So you can see this data is really nationally representative. Of course, the red part here in the southeastern side, this is really dispersely populated, and in the north. And another important fact here is the Rift Valley that starts from Palestine and extends all the way down to Uganda actually passes through Ethiopia. It divides the country into two. So this part is the Rift Valley, the red part, where you have really low rainfall. The green parts are the ones that we have more than 2,000 millimeters of rain every year. So around 99 million people in 2015, that is the time that our second wave of the data was collected. 81% live in rural areas. Ethiopia has a tropical monsoon climate with wide topographic induced variation. There's a cool zone, temperate zone, and hot zone. In the cool zone, it's about 2,400 meters above sea level. Temperature ranges between freezing point to 16. You know, everyone thinks about when, because of the prevalence of drought, people think that it's all, everywhere desert there, but we have even freezing point kind of areas. Temperate zone, which is 1,500 to 2,400 millimeter above sea level. That's 16 to 30 degrees Celsius a year on average. And the hot zone, which is, these are the arid lowlands, 1,500 millimeters below sea level, above sea level, or below that. So the temperature ranges between 27 and 50. So these are mostly, like I said, these are the red parts, actually, where you have really the lowlands. Annual rainfall, again, ranges between 2,000 millimeter in the really wet areas to 100 millimeter in the desert side. Predominantly agrarian, 35% of GDP, 68% of employment, and 90% of export earnings. The livestock sector contributes about 45% of the agricultural GDP, 90% of the overall GDP, and 19% of foreign exchange earnings. So livestock is a source of livelihood, input to crop production and income and transport. It has huge potential to improve the lives of millions and play a role in poverty reduction. But the country did not really to take advantage of this rich sector because output and productivity is really poor and managed mostly traditionally. More on the climate of Ethiopia. It's vulnerable to climate change, significant climate change since 1960, more than 15 droughts, average temperature increased by more than 1 degree Celsius, and the average number of hot nights increased by 37% in this period, in 30 years, 40 years, 50 years time. Accelerated evapotranspiration and reduced soil moisture, especially in the central regions where you have significant decline in yield. The significant variability in long-term precipitation with overall decline. So you can see that rainfall or average rainfall declined by about 20% actually in some places, such as the South Central in particular. So clearly the impact of climate change is visible. So the data that we use is two waves of the Ethiopian Socioeconomic Survey. These data is organized by the World Bank, Living Standard Measurement Survey, and the Central Statistical Agency of Ethiopia. Like I mentioned before, it's nationally representative. It contains both urban and rural households. It was collected actually 2011 and 12, and then 13 and 14, 15 and 16, but we use these 13 and 14 and 15 and 16, the two waves, because that's the drought happening between the two. But we use the base year or the first wave to see the parallel trend assumption holds actually, because we're using difference and differences. Attrition in the rural part of the data has been less than 2%. In the urban sample, it is more than 15%. So one has to be concerned with attrition, but in the rural sample, that's not a problem when we're using the rural sample. Weather data, we use what we call the CRIPS data, which is from the Climate Hazards Group infrared precipitation with the station data. Previous studies used both self-reported and meteorological data, but both, in my view, are problematic. Subjective data self-reported is, there's a serious error actually in reporting. People report drought when there is not drought, and people report no drought when there is actually drought. Meteorological data suffers from missing observations. We tried for a previous paper just published in the American Journal of Agricultural Economics. The number of meteorological stations in Africa declined from 3,500 to about 500 in 2010, so just about 20 years time. So Ethiopia has about 0.303 stations, like per woreda, which is per district. So this is a large area, geographical area. So we have regions, the country is divided into regions, and then the regions have zones, and the zones have woredas. And then you can see that per woreda you get only 0.03. So there's a clear there, and most of these are stationed at surplus agriculture producing areas, because you don't put in razor stations randomly. You rather put them where they are needed most. So that will introduce a systematic bias, and we show that actually in a recently published paper. So we use the CRIPS data, which is a good alternative produced by the Climate Hazard Center at University of California, Santa Barbara. Contains about 35 years plus quasi-global gridded rainfall data. So you have data in 5 kilometer by 5 kilometer grid using different climate kind of models and some in situ station data. Useful for trend analysis and drought monitoring, and extensively used by other researchers. So one important issue is on how to define a drought. So we define drought when there is a rainfall that the village experiences is below the 20th percentile from the long-term mean. That means for the past 30 years. We check the robustness, of course, to using alternative definitions like 1 standard deviation below long-term, etc. And the results really remain robust. So this is a simple sample data at baseline. Well, except this, the first variable affected by drought. This is not baseline data, so we just erroneously reported it there. But everything else is baseline. At baseline, the groups were producing 5.192 livestock owning in tropical livestock units. Total meat production was about 150. 80% of the households are headed by male, 46-year-old age, and 34% kind of literate. They can write and read, and they have small land holding, which is 1.69 per hectare. But look at the drought variable. 51% of the households in the sample experienced a drought in that year. So it was major, and that was affected the whole country. Yeah, these are like standard representation. Household size 5.36 members on average, in half female, and non-farm enterprise 27%. 2,711 kind of households at the baseline. So simple mean comparison in livestock holding, no significant difference between drought affected areas and the control areas. And of course, there's a slightly lower in tropical livestock units. They have lower number of livestock, but still these are not statistically significant. The same is milk production, 138 liters per year versus 162 liters per year. So you can see that there was no difference, statistically significant difference between the two groups in the outcome variables before drought. These are like results from the difference in differences, controlling both for both controls, not controlling only the treatment variable 47, 0.47, 0.44, given the mean value is about 5.1. So there was a 9% impact on livestock holding. So households on average lost basically 9% of their livestock. And when it comes to milk production, the effect is incredibly large. So that's 97% decline actually by 136.9 liters. This is the conservative estimate average treatment effect, controlling for all important covariates. You remember the mean values are here about 150 liters. So if you divide these changes, declines, that would be about 97%. So there's been a massive effect on milk production. This is understandable because there's drought, there is shortage of water, there's shortage of forage for animals, and feeding animals is also problematic, and obviously there will be a decline in milk production. These are outcome variables that we did not see other people have analyzed. What are some of the mechanisms that explain these? You can see that households sold livestock, so those who sold livestock reported, actually you can see that there was on average 0.17 livestock kind of sale. So they basically had to sell their livestock during drought. But this is not necessarily terrible, because there has been already a development economics literature which shows that households have known to basically smooth consumption by saving and desaving. There's some research from India and previously from the 1990s and etc. But what is problematic is if you are forced to lose your productive animals. Cattle, you can see that we divided them into cattle, small animals, and other like chicken and etc. Small animals are like goats and sheep. Cattle includes cows and oxen basically, and that are used for both milk production and also agricultural production. So you can see that the effect is equivalent. It's almost 9% decline. So a large part of the decline in the livestock was accounted by a decline in the cattle size. So that is the kind of I would say the alarming side of the effect of the shock. We did a falsification test to test for a parallel trend. That means we used the first year data, which was the drought. We used the data for 2012, 11, and 12, and we used the same definition of drought and see if drought had any effect during that time. And you can see that there was no statistically significant effect on the drought. So the key mechanism that drives the effect here is sale of livestock, most importantly cattle. The El Nino, so the key conclusions from this study: the El Nino induced drought, of course, affected livestock holding and milk production. 10% reduction in livestock holding, or 9 point something, and milk production by 97%. This is the biggest impact that we document. More impact on cattle, because cattle are used for agriculture and milk production. So this is going to likely, very possibly, a long-term impact. It would be very interesting to see what happens to these households actually 3, 4 years or 5 years after the drought, after they lost their livestock. I mean, are they still producing, given that the drought is not there anymore and there's enough rain, and this, are they producing enough agricultural production and also milk production, and did it affect them in the long term? That would be an interesting analysis. And we also show that main mechanism was a sale of livestock. So there is a clear need of safety net programs targeting the livestock holding. Of course, the safety nets that the government has been providing is to provide emergency food aid. But one final slide that I want to include for people that are really interested in working in this issue would be the response of the livestock sector to climate change and rainfall, temperature, and humidity, etc. Both for dairy production and livestock production and growth has not been investigated significantly. I think there was like a few studies. We had some EfD colleagues from Kenya actually a few years ago on the livestock sector, climate change and livestock sector kind of analysis, but what we know is really very limited. Most recent research in crop production actually says that controlling for climate variables doesn't mean necessarily rainfall or precipitation and temperature. Other climate variables are also very important in their interaction, like humidity, heat, stress, and etc. And I think it's very helpful to see the impact of those interactions or those climatic variables on the livestock sector and livestock holding and dairy production by smallholder farmers. And also the long-term consequences of transitory shocks in general, but the long-term consequences of losing a livestock, a productive asset like livestock, in the context of a smallholder farmer in particular on crop production would be very important. Thank you for your attention. Thank you, Martin. I'm done. We can take questions now.
Great. Thanks very much, Yonas. That was a fascinating presentation, and it really highlights to us the vulnerability of countries like Ethiopia to climate variability and climate change. I was specifically also interested in, what you may have mentioned that, but the importance of livestock to the overall economy, to GDP, especially when you mention these kind of alarming impacts on things like milk production. I was just wondering, what is the knock-on effects of that to the economy, and also the percentage of that livestock is of overall household wealth. The other question I had was also whether you were able to look at duration of drought, or do you just look at drought as an indicator? Because I would imagine that duration of drought might sort of shorter periods may impact milk production, but then longer impacts sort of lead to sale of cattle, and whether that could be interesting. Shall I give you some more questions from the floor, or do you want to respond first?
Yes, maybe a couple of more questions.
So Alejandro asked a question. He said, great presentation. He said, at some point during your presentation, you mentioned impacts on development outcomes, and asked if you looked at that, for example, school attendance or female employment. There was another question from Mook Bangalore, who said, he also thank you for the great presentation. He wanted to know whether you explored the impact of drought on consumption, and specifically because you looked at smoothing due to livestock sales. Did you find smoothing on consumption due to livestock sales as hypothesized? And then the second question was, what is the correlation between self-reported drought measures with the objective drought metric that you mentioned? I'll throw you one last question from Salvatore, who says, he says, thanks for the inspiring talk, and then asks, did you explore some heterogeneous impacts like gender, wealth, etc.?
All right. Thank you very much. These are all very interesting questions. Maybe I can start with your questions, Martin. So if I got it right, the first question is the livestock sector plays a significant role in the economy. It is responsible. It constitutes about half the agricultural GDP and 19% of the GDP overall. But I don't think people analyze that. That would be very interesting, and especially using kind of economy-wide modeling, I would guess, if you want to see the impact on that, or using some sort of back-in-the-envelope analysis. But our kind of approach was more limited to the micro aspect.
Sure.
Duration, I think this is important. The way we defined is we used alternative definitions. How much rain did the household, so you can, the good thing about this rainfall data is you can track it five kilometers. So we're not using really one rainfall data for the whole village, unlike previous studies. So you can, there's variation on the rainfall within the village, but we haven't checked to, I think it, I will have to double check with my co-author for sure, but I think this drought was kind of large scale and somehow similar in the entire country. In the villages that have been affected, they were exposed to the drought almost at an equivalent kind of intensity and duration. That is my understanding. But we will definitely check if there is any difference in the duration. Maybe looking at the rainfall distribution, this is worth investigating. I will write it. Other outcome variables, yes, some other authors evaluated the impact. I mean, the impact on consumption, how drought affects consumption in general has been well studied, actually. Many papers that I know of, at least in Ethiopia and other African countries. But there is one paper investigating consumption on this, using this data as well. So we do not really want to repeat that. We wanted really to focus on outcome variables that have not been covered. I remember another study on child nutrition as well. So there is a study on child nutrition and consumption. So other studies have done that. So our focus is more on the livestock. Self-reported versus, well, we did not really check on this one. I think we can do that. But I think my understanding is there's quite a major difference in the way when households report, they experience the drought versus when you are using a standard definition of drought using kind of climatic data. But I don't have the figure, but definitely we can check this. But previous studies, I think they're not really reputable when it comes to analysis in economics. Heterogeneous impact. Yes, I think we did some sort of, well, there's a number in the paper that definitely will be available, Salvatore. We will send it to you as well to have a look at it. We did heterogeneous impact based on wealth, if I remember, but probably one heterogeneous impact to consider is, you know, gender of the head of the household. But yes, we did a few heterogeneous tests, checks.
Great. I'll ask you another question that came from Kecha Tai. He want to know about livestock insurance after drought, whether you saw any evidence of that. I'm not sure if that was, yeah. And then Mark Hewland says, he's sorry if you missed it, but do you know about revenues from sales? And in particular, are smallholders in drought forced to sell when prices are low, or are there benefits in the form of selling when price is high that might partly compensate for negative impacts? And there's also a couple of questions here from Dumbala Gelo. The one was a decline due to direct loss, death of livestock assets, or sales to smooth consumption? And the second one, are your estimates heterogeneous across subsamples, say defined by wealth threshold in the sense of Michael Carter's type of work? And then lastly, is there any thoughts on policy prescriptions, safety net or insurance market development?
Yes. All right, thank you. Livestock insurance. I'm not sure if we have that information, but I think that is, of course, one of, you know, these, most of the time, obviously, the rural sector is not attractive for the modern insurance company because the risks are very high. But we will check if there is any question on insurance, but I don't think there is. I'm not sure if there is any question on whether they insure their livestock or not. I don't think so. I think that my answer would be if they were paid out insurances, I think that would have been reported in the shock coping mechanisms. Revenues for sales, again, so the data is limited here. What they report is whether they sold the livestock. So what is the reason for losing the livestock? Is it because of death or is it because of sale? So there was sale for sure, but whether they got good prices for the livestock, it would be hard to tell. One, this data is not collected, but you can use common sense. In drought times, actually, the price of livestock goes down because most households are desperate to sell. So there would be basically excess supply of livestock in the market and the equilibrium price is driven down. So the last question was the decline due to death. Yeah, I think the presentation indicated that it was largely because of sale. Households sold their livestock, and the effect on cattle was significantly higher actually than small animals.
Great. There's one question here about policy. Were these farmers abandoned or supported by policy to encourage a better response?
Yeah, this is a good question. I mean, Ethiopia has been experiencing drought several times, so there is quite a good response mechanism. But my understanding is these supports target directly food aid. So they deliver, of course, they save lives of people. But I don't think, and I'm not aware of any safety net that directly targets the livestock holders to protect the livestock. Of course, one of the reasons they say is the reason that they quickly give people food aid is so that they don't save their livestock, because livestock is a very important asset. They use it for, especially cattle is used for agricultural production and meat production. So, but still there has been significant sale. So that might be because then it would be risky to keep the livestock because there's no enough feed and there's no enough water, and then if you keep the livestock, then they will die. And that might be because of that. So maybe one policy option might be to directly target livestock holding as well during droughts.
Great, thank you very much, Yonas. Yeah, it was a fascinating talk, and we're interested to see where this work will lead. I'm sure there's a lot of new potential on the horizon, and there's still so much work to do, right?
Yes.
On that, Thomas, you were added as a panelist, and I think you've got some burning question just before we close. We're about to hit the deadline, but Thomas, we can always make a space for you.
Yeah.
Very kind of you, thank you. And thanks for a great talk. I was wondering also about policy and adaptation, which is a big topic we seldom talk about, but should talk about more. And I think there is a strong perverse mechanism when you see a drought coming and you feel that for your family you need 10 cattle, then you better try to get 20 cattle, because otherwise if you only have 10 and half of them die, then you'll be left with 5. And so there's a sort of a motivation to overstock as an insurance mechanism for the family. Yes. Or even village for the local level. But of course, at the aggregate level, the more cattle, the higher is the risk that they all starve. And so I'm wondering what can be done at the national and at the local level in terms of adaptation and policy.
Thank you. This is a very important point, Thomas. In fact, there's also an important thing too that I probably did not include in my presentation. In Ethiopia, there are also households that are entirely dependent, cattle herder households, that are not significant, their proportion is very low, probably 15% of the sample or something in this data, but that's a nomadic kind of society. They keep quite many livestock. So keeping livestock is a way of life in their case. But in our analysis, because we wanted to make it consistent, their sample is not representative actually. So they have outlier number of cattle that will drive the results. So we excluded the sample of those cattle herders. So we focused more on smallholder farmers that are mainly dependent on crop production. So they keep livestock. So they use livestock for agricultural activities and also as a way to store, basically as a way to store their wealth. So I think there are, in terms of adaptation, there are a number of possible policy options, which like I said, is especially in the times of drought, one thing to do is to target these livestock holders and provide livestock specific support. One option that would be, in my view, that comes to my mind. But of course, happy to hear more thoughts on this.
Thank you.
Thank you.
Great. Thanks, Thomas, for jumping on. I actually forgot that I could add people to the panel, and so it's actually a great way to do it. Yonas, thanks very much. This brings us to the close of our session, but this was a really great kickstart to the day, and we hope to see you all in the next session.
Yeah. Thank you.
Thank you.
Thank you.
Nice to see you, Martin.
You too, Thomas.
Entendimiento y razón.